In order for us to make the transition and start using inferential statistics, we need to have a process in place. So we're going to talk about how it is using hypothesis testing that we can start to make claims about the data that we observe. And what we talked about was to be more scientific, to make it look like we're following the same procedure. Whenever we engage in hypothesis testing, we're going to follow these steps. We're going to do these things in order to make conclusions. You will do this for the rest of the course. Everything we do from here on out is in this hypothesis testing framework. So last class what we did is we talked about the difference between a research hypothesis and a null hypothesis. The research hypothesis is what you think exists. So what the relationship is that you think. The null hypothesis is always that there is no relationship. So if we start off with a question about is there a difference between men and women, your research hypothesis is there is a difference between men and women. Your null hypothesis is always there's not a difference between men and women. What we're going to do today is talk about this step. Define your decision rule. Now, I haven't really taught you about any tests yet. I've given you the framework of how z-scores operate, and we've talked a lot about probability distributions and what the area under the curve means. But that's the next thing. So after today, after we talk about the decision rule, we'll start talking about different tests that you can use. And I ended last class by giving you this example. Anybody thought about this the last couple of days and figured it out? I hope you do, because I haven't taught this in a couple of years and I've kind of forgotten the point of this, but we'll try it again. The story of Jason. All humans are mortal. My theory is that Jason is a human. I kill Jason and that he dies. Does that prove that he's a human? The answer is not necessarily, because there is an alternative. What else could Jason have been? Cockroach. My pet cockroach. Okay. He's my roommate. So there is an alternative there. Jason is shredded, set on fire, and sprayed with Raid, and Jason still lives. Jason is not human, right? Either that or he's one tough man. Cockroach, computer, indestructible object. I don't know. Once you usually shred something, that's a, you put it in pieces. I don't know. The reason I mention this is because we're going to start thinking of alternatives, right? We need to think about, is there an alternative explanation to what you've found? I think the reason I was going to go here was to talk about hypothesis testing. So here's what happens. We've got a very simple framework. Either your hypothesis is true or it's false. And what we're looking for is evidence that allows us to reject the null hypothesis. That's what we're looking for. Because we're trying to reject the idea that there's no relationship. So we have to find proof that there is a relationship. So when you're constructing a hypothesis and a way to test it, you're going to have your null hypothesis and your alternative hypothesis, or your research hypothesis. You're going to perform a test, and then you're going to decide, based upon the results of that test, do I reject the null hypothesis? But you're not going to know for sure, just like you're not going to know for sure what Jason is. So the goal to, and I'm putting this in air quotes, and you better in your notes too, prove your alternative hypothesis is to reject the null hypothesis. Everything you do is framed about rejecting the null. But remember, we're dealing with samples that are drawn from a population. We're doing this in the frame of that there's probability out there. So what we need to do is reduce the chances that we're wrong. Because what you end up with are errors. If you do, let's say, you reject the null hypothesis, but it turns out that the null hypothesis is true. So if you say, this is known as a false positive. Let me do this real quick. Yes. A false positive. Right. A lot of this discussion comes from medical literature, and the best way that I can describe this scenario is with pregnancy tests. Sorry, I know it's not social or political, but you know, someday most of you will stand over a pregnancy test praying to any god you could find about the outcome of the test, whether it is positive or negative. Okay, so let's go with what is a pregnancy test? Well, the assumption is that you're not pregnant. That's the null hypothesis. Okay? In your average everyday state, when Joey pees on the stick should say that Joey is not pregnant. Okay? But one day, Joey pees on the stick and it tells him he's pregnant. That is known as a false positive. The test has detected something in Joey's urine to signal, there's elevated levels of, and this is where I really need to pay more attention, something in his pee. Usually only pregnant ladies have that. That's what we would call a false positive. The test indicates that Joey is pregnant when we know he is not. Why is that bad? Well, A, because he can't be pregnant. Any other reason why that's bad? What might happen to Joey if he thinks he's pregnant? No, okay. Let's just say he could go, wait a minute, I'm pretty sure I can't get pregnant. There must be something really, really wrong with me. Right? And that would be bad for Joey's mental health. Right? His anxiety is going to go up. He's thinking he's sick. That's bad, right? Right? So if you get a false positive in a test, you've got cancer, you have 3 weeks to live, you're going to go off and you're going to make some bad decisions. Well, yeah, hopefully you go to the doctor. Let's just say, hey, doc, you know what the first question the doctor's going to ask is? Why are you peeing on a pregnancy test? And his answer's going to be, well, Dr. Wood said, right? I just wanted to find out. And I got a false positive. So something must be wrong. That's known as type 1 error. We have rejected the null to accept. We rejected the null when in fact the null is true. So in our example of men and women, you would say there is no difference between, or excuse me, you would say there is a difference between men and women when in fact there is not. That is known as a type 1 error. Can we all agree that those are bad? Okay, we probably don't want that. The other type of error that you could have we call type 2 error. This is a false negative. So Joey pees on the stick. No, I'm kidding, right? I think we exhausted that one. And the stick says he is not pregnant, but he actually is. That doesn't make any sense. Okay. So a false negative, where you do not reject the null hypothesis, but you should have. Because Joey really was pregnant. See, this doesn't work anymore. Let me ask you a question. Which one is worse? Get the pregnancy example out of your head. Which is worse, the false negative or the false positive? Is it worse to say that there's a relationship where none exists, or is it worse to not say that a relationship exists where one does? Now remember, you're scientists, and you're trying to make claims about how the world works.
Well, it depends on what the case is.
That, which is worse? Saying that men are smarter than women when they're not, or not saying that men are smarter than women when they are? Why? Why is it wrong to claim that there's a relationship when there isn't, rather than missing a relationship where there is? Well, it's being wrong. Why is it worse for us?
Because you're making a false claim.
Yeah, but what are we doing with that claim?
Reporting of evidence that exists.
We're saying that here's our data that suggests that, for example, what is that? A iced coffee makes you pregnant. Why is it bad to walk around saying that iced coffee makes you pregnant? People will believe you and then do what? Change your behavior, right? So that's the argument we're making, is we're telling you something that is false rather than not telling you something we don't know is true.
Then what if
I'm saying they're both bad, but I want to know which one is worse.
But what if you had a situation with cancer? You got tested for cancer,
Mhm.
and you had a false. If you say you went to get tested and to get whatever they do, and it's come back as a false positive, you get initially you're scared, but then it comes back as a false positive. That's one situation. The next situation is false negative, where they don't detect that there's cancer, and there actually is, and you end up dying from it because they don't detect it.
Here's the thing, right? Both are bad.
Yes.
But which is worse? To tell somebody that they have cancer and then they go and get chemo and radiation, which suppresses their immune system and kills them, or not know if they have cancer and say, we don't know if you have cancer, and then they actually do. So one, you're actually creating a treatment for a problem that does not exist, and in the other one, you're not recognizing a condition that does exist. I will grant you that both are bad, but which one is worse? Okay, Joey's with me. We can move on. Everybody else with me? Jake's always a contrarian. I agree, they're both bad. Just as if it were, yes, having cancer is bad. I will say that, okay? I have no problem saying that. But if there's one that we're trying to reduce the incidence of, which one is better for us as scientists? The first one. Okay? If we have to go back to the pregnancy test thing, fine. Would you like to take a pregnancy test that is frequently wrong in telling you that you're pregnant?
Yeah.
No. Why? Because then the test has no value to you. Right? Then you basically say, well, that's pregnancy testing. It's wrong all the time. then itself becomes meaningless. It's better to miss, right? To not assert that there's a relationship where there isn't, than it is to assert a relationship where there isn't. Okay. We agree that both are bad. They're both errors. But it turns out that the way that we do hypothesis testing, we try to minimize the type 1 errors as much as possible. This is going to get confusing because I'm going to use beta in a different way at the end of the semester, but we call a type 1 error alpha. 1, A, first letter of the alphabet. Type 2, B, beta, second letter of the alphabet. Alpha, when we try to keep alpha small, we do that by making a choice. We make a choice about how certain we want to be in terms of probability. Now, beta we can actually help improve by having larger sample sizes. But alpha is a decision that we make. We want to keep it as small as possible, right? Because we want to make sure that we're not saying that there is a relationship, reject the null hypothesis, when we shouldn't have. We want to keep those incidents down as much as possible. When we determine what alpha is, we're establishing our decision rule. For the most part, in social science, we want to have 95% confidence in our relationships. So what we do is we have a decision rule of 95%. And what we do is we set alpha to be 0.05. That's the norm. You could set it to be higher. You could say, I want there to be a less than 1% chance that I'm wrong. So you just set that to something that's less than 1%, 0.01. This is a decision that the individual researcher makes. There is the custom in social science, again, to set it at 0.05. That's our custom, 95% confidence. Because that's pretty close, but yeah, you got a little room for error there. Has anybody heard of the of power posing? Aaron, tell me about power posing. Would you care to come up and demonstrate a power pose? You both should have to get up here. Yeah, both of you come up here and demonstrate to the class what a power pose. No, just go right up to the front. Yeah. This is the only power I have. Come on. Actually, I want to do it because she's got her rain boots on. All right. Do the Wonder Woman one. Yeah, the hands on the hip thing. All right. This is a power pose. You got any more in your routine? Okay, you can sit down now. A few years ago, some psychologists came out with research that said women particularly should engage in power posing to increase their self-confidence, particularly at work. My favorite power pose is the putting the feet up on the desk, also known as feeling like a boss, right? The argument is that if you do these routinely before an event like giving a presentation, that your confidence will go up and your performance will be better. Am I saying this correctly? The authors of this study that came out a few years ago, I think it was about 5 years ago, there was a famous TED Talk. One of the authors did one of those talks that explained their research. Just last week, there was 3 main authors on this research. One of the authors came out and said, I want to disavow myself from this research. One of the arguments that she made when she said there are problems with my research involves their decision rule. She said that they set the decision rule too low, like at 0.9, instead of at 95%. And there's this big, I don't want to say like controversy, but in the field of psychology, there's this big discussion right now of how it is that we are manipulating this decision rule to achieve the results that we want. It's called, it's kind of funny. It's called P hacking. I haven't told you what P is yet, but we'll get there. So this discussion right now in statistics is over P hacking and how researchers, when they define their decision rule, are making some questionable assumptions. So when I teach you how to set this, you have to understand that it's subjective. It's what you decide it to be, but it's also an area of criticism. Why did you do it this way? The P comes from probability. This is where the P comes from. Probability hacking. Okay. So you're going to set your decision rule. Those are the errors you can make. Now, if you have passed the limit that you said when you set the probability in the alpha, what you are allowed to do as a researcher is known as rejecting the null hypothesis. This is what we're aiming for, right? We want to reject the null because we want to find the relationship that we theorize exists. The reverse of that would say we want to find no relationship because we want to have our iced coffee not make us pregnant. So this is the goal if we're asserting that there is a relationship between two things. If we do our test and we correctly retain the null, you would say that you do not reject the null hypothesis. I will disown you as human beings if you ever say that you accept a null hypothesis. You never accept the null. You just haven't found the evidence yet to reject it. You got that? You will be dead to me if you ever accept a null hypothesis. You just can't reject it yet.
What if we just say our hypothesis was the opposite?
No. Stop it. Don't get cute. Do not get cute. My findings with the data I currently analyze do not allow me to reject the null hypothesis at this time. yet. Therefore, I will collect new data and better data and a bigger data set. You never, ever, ever, ever accept the null hypothesis. Never. Add this to the list of things you get disowned for doing. I forget what the first one was. Using Excel, thank you. Somebody create the list. Things Professor Wood will not allow you to do. 1, use Excel. 2, accept null hypotheses. 3, write the word thing in your papers. You're not allowed to use the word thing when you're writing. You're allowed to use it when you're talking, but you're not allowed to use it when you're writing. All right. We'll see if we can add to that throughout the semester. All right. So we're trying to avoid making errors, and we're sure as hell never accepting a null hypothesis. So what we're hoping for is that our analysis allows us to reject the null and therefore accept the alternative hypothesis. Which is kind of the point of my whole Jason is human thing. Right? We haven't proven that Jason is not human. We just can't prove yet that he's not human. Yeah. Okay. We talked about that. Okay. Here's how we do it. Because again, the only thing you guys know is how to do this with a curve. So, it turns out that when we're talking about alpha, we're going to use our normal curve distribution. And what we're going to do with alpha is we're going to say that alpha is in the tails. It's the outliers. So if we have a decision rule that is 95%, then we take the remaining 5% and we put it in the tails. So that means you put, if it's 95%, which gives us an alpha of equaling 0.05, and we have to put it in 2 tails, this area is going to equal 0.0250. And we're going to put a little bit of it over here because it's symmetrical. The reason that I put it in both tails is because when I'm talking about my hypothesis, I'm saying that there's a difference. So if I'm saying that there is a difference between men and women, the null hypothesis is that there's no difference. We can actually have 2 alternative hypotheses. And we did this a little bit last time. So my null hypothesis is that the difference is 0. But what are 2 alternatives to that the difference is 0?
It's not 0.
That's 1, but give me that in 2 different ways. Okay, it can either be less than 0, which would mean that the female number is bigger and that females are better at something than males. Or it can be more than 0, which indicates that the male number is bigger and that men are better at something than women. So that's 2 versions of the men and women are different hypothesis. That's known as a directional hypothesis. If you have a directional hypothesis, you can put all of the area in one of the tails. Right? So if your alternative hypothesis is that men are better at something than women, you could put all of that 0.5 over here. It's known as a one-tailed test or a directional hypothesis. Now, if you do that, you're making your rejection area a little bit bigger. That's also part of the p-hacking scandal. Now, scientifically, it makes sense. If you are arguing a directional hypothesis, it makes sense to put all of that area in one of the tails. Your instructor did that in his doctoral dissertation because it made sense. I was arguing that there was a directional effect. It would make no sense for the opposite to be true. So if public opinion goes up on an issue, judges should also go up on an issue. Wouldn't make sense for it to go down. So I put all my area under one tail of the curve, which allowed me to reject the null and make a claim. Some people are saying, well, that's wrong. Unfortunately, mathematically, it's correct. All right. Now, because I've told you that this is all in reference to the curve, I know you guys have the ability to find the area under the curve. You do that with what? Z-scores. So now we have to find a way to calculate Z-scores when we have differences. So it's a two-sample test or differences of means test. And we're going to start that probably next week.